Alright, let's take a look at the tutorial 19 homework. So here's the code we have for the update, the keyboard update function for dude. And yeah, so you add to the x, you add to the y, speed times dt. And speed is just 1. So basically, if you move left, right, up and down, you're going to be moving by 1 pixel per second, like this. But what if you move diagonally? Well, that's going to add this and this together. So you're going to get this, right? And as you can see here, this motherfucking vector is longer than if you're just moving horizontally. So if you move diagonally, the dude actually gets a speed boost, which is probably not what you're looking for. You want him to move the same speed, whatever direction he's moving in. So if you draw a circle around here, or we can call that a circle, even though it's not really one. His speed when he's moving diagonally should actually only be here, but it's here. This is actually, the length of this vector would be root 2. If this is 1 and 1, this is root 2. But anyways, so it's no good. So how do we solve that problem? Well, it's quite simple. All you got to do is you go into update here, and we're going to just create a vector here, call it velocity, and it should really just be delta, but it doesn't matter. We'll call it velocity, we'll set it to 0 and 0. And then if you press right, we add 1 to the x, subtract 1. So we get a vector that is much like the addition and subtraction that we got here. But before we then update the position of the dude, we normalize our velocity vector. Then we multiply by speed and dt. So normalizing it makes it so that the diagonal is now shrunk down to the length of 1, just like all these other guys. Normalization at work. Very nice. Now, for the mouse controls in the Pooh game, first thing we do is we add another function to dude, and we call it update, just like the other one, but instead of taking a keyboard, it takes a mouse. And then in dude.cpp, we're just going to update based on the mouse input. So what we do is first we check to see if the left button of the mouse is being pressed. If nothing's being pressed, we don't do anything. And if the left button is being pressed, what we do is we get the center of, basically we get a point that is the center of the dude. So we calculate the position of the dude, and remember the position vector for the dude actually points to the top left corner of the dude in the game that we're currently doing. So to get the vector to the center, we take the top left corner and we add to it a vector, which is just the width of the dude divided by 2 and the height divided by 2. So that goes from the top left corner of the dude to the center of the dude. So now we've got a vec2 for the center of the dude. Now we want a vec2 pointer. What is this? Why did I name it that? So this is just a vector that goes from the center of the dude to the mouse pointer. Oh, that's why it's to mouse pointer. So if we subtract the center of the dude from the mouse pointer, we get a vector from the center to the mouse pointer. And we just do that. We call mouse.getPositionX, getPositionY. We feed that into a vec2 constructor, and we subtract the center. So now we've got a vector which is the delta from the center of the dude to the mouse pointer position. Then all we gotta do is normalize that vector, because the vector from the dude to the mouse pointer is the direction that we want to move in. We normalize that because we don't want to move faster if the mouse pointer is further away, right? We want a constant speed. So we normalize that, and then we multiply by the speed, and we multiply by this time step. Add that to the position. It's quite simple. And finally, in game.cpp, instead of calling update with the keyboard, we call it with the mouse. And that will call the other overloaded version of update. Now I'm going to create a branch at this point here so I can show you something. So here's the branch after I have, let's reset here. Where is it? Test branch. Yeah. So here is the point where I implemented the mouse controls. Now if we run that, we see that it works fine, except for when you drag off the left side of the screen. And then he moves in the opposite motherfucking direction. And same at the top. The bottom is fine, but the left and the top are bad. So, and I was wondering if I did something wrong in my mouse control code, but actually this is a bug that was in the framework. So if you encountered the same thing, then I hope you didn't spend too much time pulling your hair out there. But I'm gonna put a note in the video so that let people know that there's a bug in the framework. So hopefully you won't, go crazy trying to figure out what's going wrong there. But anyways, so the solution to that problem is, if we go into changes, here we go, view history. So where am I now? Master? No, I don't want to be in master. Talking and doing shit at the same time. It's not my cup of tea. I want to go to branches and T19 development. Right. All right. Now we want to view the history of this thing. There we go. So Houston, we have a problem, and the bug was in framework. And I fixed this. I also put this fix into the framework, the framework on GitHub, so you don't have to worry about it being in there. If you start a new project from the GitHub, you'll have this fix in there. But anyways, I was using some macros from the Windows API to get information out of this 32-bit value, to get two 16-bit values out of here. You don't have to worry about the details, but long story short, in MSDN documentation, Microsoft's documentation, they say do not use low word or high word to extract the X and Y coordinates. Use make points to obtain a points structure. So that is what I did, and it fixes the problem. You don't have to worry about this bullshit. Eventually, I'm going to go over all of this Windows handling bullshit. But for right now, you don't have to worry about it. Just know that it is a thing that was in the framework, and I fixed it. Now, the last problem is if the dude reaches the mouse pointer, I don't know if you can tell in this video, but he vibrates back and forth because he can't quite get to the position of the mouse pointer. So he keeps overshooting it, going back and forth and vibrating in space. And to fix that, let's go back to T19 development. What I did is view history, fix the amazing vibrating dude. And all I did there was, instead of always moving, there's a dead zone radius of, I guess, about square root 2. So we check to see if the distance is greater than some threshold, then we update the position. Otherwise, we just don't move at all. So that means that when he's very close to the pointer, he'll stop moving, and that will prevent him from vibrating back and forth in space. But that's the homework for tutorial 19. If you got any comments or suggestions, leave them in the comments below, or if you got some questions or problems, catch me on the forum or on the Discord. And I'll see you soon with some more C++.